talking about removable discontinuities. So, what are removable discontinuities? Well, they're essentially points on the graph, empty circles on the graph, where your function is not defined. So they're as opposed to asymptotes, which are lines. Okay. So let's look at this function. And you won't always be able to know in advance whether you have a removable discontinuity. But I'll let you know that in this case we do have a removable discontinuity. And you'll see this from factoring. So we'll factor the top and the bottom, and we get on the top you get x plus 1 times x minus 2. On the denominator you get x plus 2 times x minus 2. So what happens is the x minus 2 factors cancel out. And your function is essentially this function. It reduces to x plus 1 over x plus 2. It has the same behavior with the exception that at x equals 2 you have a removable discontinuity at x equals 2. As in, if you filled in that point, you could then make the function continuous around x equals 2 simply by filling in the point, which would involve not including these extra factors in either your numerator or denominator. Okay, so it's also important to note that if you were just going about this as usual, then you would look for your vertical asymptotes by factoring this denominator into x plus 2 and x minus 2, and then you might say your vertical asymptote is x equals negative 2, which is true, but you might also say it's x equals 2. But this is in fact not quite accurate, because you'll have to revise this in the case when you learn that you have a removable discontinuity at x equals 2, which you would find by factoring the numerator and seeing that it has the same factor in common that cancels out with the denominator.